So now describe the characteristics and applications of a stack. Construct algorithms using access methods of a stack, and then same thing for queue. Difference between a stack and a queue. Do I dare try it in Photoshop? I'm gonna. Alright. In general terms, a stack versus a queue. Stack follows a last in, first out structuring. Last in, first out. So if I do a stack of pancakes, it's Shrove Tuesday, yesterday actually. Anyway, stack of pancakes. There's the first pancake that's in. Palachinki for those. Okay, here, and I'm gonna, well, that's the first pancake in. Here's the second pancake on the stack. And the third pancake on the stack. If you have a stack of 4 pancakes, the last one in is the first one out. You can't grab the bottom pancake and pull it out because there would be a mess. So that's a stack. A queue, those are pancakes, of course. A queue, Q-U-E-U-E. English is that way sometimes. Queue. A queue operates in a first come, first serve, or first in, first out basis. So, I'd like to say this is the ISP cafeteria, but it's not, unless Miss Riffle is running the show. First in, first out. The first person in was that fella, and the last person in was Mr. Richards. With his math book. The first person served at the cafeteria is that person. That's a queue. First in, first out. Who will be the last one served? Mr. Richards. So that's the difference between the two structures, a stack and a queue. Because some things work better as a stack, and some things work better as a queue. A lot of things work better as a queue. In fact, most things work better as a queue. It makes sense. The first one there is the first one looked after. But one example here actually is recursion. Because if you can remember recursive, we had that like print whatever, right? Well, it got interrupted by another call of print whatever. But that got interrupted by another call of print whatever. And so on and so on and so on. And so finally we had a resolution. And when we had the resolution, what was the first thing off the stack? The first thing resolved? What was the last thing in there? And then the second last thing. And the third last thing. And the fourth. So there are things that happen that way. Another thing that you're going to learn in higher level theory is interrupts. An interrupt is when you're in the middle of doing a process. So you're in the middle of doing, say this is a process. It's doing, I noticed when I was doing my finder that it isn't doing it anymore, but it was indexing. Indexing is something that happens on a computer when there's time. So let's say it was indexing, but then something more urgent came up, like launching Photoshop. So launching Photoshop was the process that took over the indexing. But then in the middle of launching Photoshop, maybe my antivirus software told me I was updated. So that interrupted. That was, it's called an interrupt. And finally, let's say that there was a hard drive crash or whatever. It's kind of silly, but that's more important. So I'd handle the hard drive crash at the top of my list, then I'd handle my, I forget what it was, and then I handle my Photoshop launching, and then I get back to my indexing. And so sometimes the last thing in is the first thing that you want to address. So how do we do these in programming? Construct algorithms. So the characteristics, basically the characteristics of a stack are last one in, first one out. Characteristics of a queue, first one in, first one out. Constructing the algorithms gets a little bit more fun, and we tend to use these access methods. And this is where you two are the lucky ones, and you get your own PEZs. So these are a stack. First one in is the last one out. So go ahead. This doesn't translate so well to video. But yeah, put a few in and take a few out. Do you know how they work? Do I know how they work?
I don't know.
And why we pulled out the PEZs now is they pop out, right? They're on the top of the stack, so when you lift up Donald Duck's beak, one pops off the top of the stack. And if you want to put them on, theoretically you can push them back on, but I guess you got to pull this out. So it's not the perfect pushing mechanism, because you're basically pushing them on. For crying out loud. Yeah, you're pushing them on all at the beginning, and these are kind of tasty. So you can pop one off and pop another off, and eventually you're going to know if is empty. All right, so construct algorithms using access methods of stack. And I do have a great video here, which there's no use for me to do in these code camps right now. It's all here. It's 11 minutes, and it talks about stacks. I'm just going to jump into the middle of it, maybe to get myself kind of warmed up, and I'll talk a little bit about wherever I am right there. So this does go beyond. Well, no, it doesn't. It doesn't go beyond what's required. It goes beyond what's required for your dossier, but your understanding of this will be required if you're doing HL. So I'm going to try to jump into the middle of this.
Head. So after having done that,
go full screen.
Head
and watch for 30 seconds.
Assigned current head dot get next. So the head is no longer this. The head is that. And so effectively, the list is now there. The queue now starts with Sue. Now, this is still in memory, there's still Bob, but we can't access it anymore via the list because it's not part of the list anymore, because we only access the list from the head. So, there you go. We have dequeued Bob from the list.
I guess what I'll do with this video, over top of a video, to point out, without doing it in Photoshop, is that the way both lists, well, both stacks and queues as lists, the way they work is that each individual part of the list is a node. You know, you have a template class, and I'll show you this and we'll do it, or copy and paste it and work with it a little bit. But basically, you've got a linked list of nodes. That node is attached to that node, is attached to that node, is attached to that node. The question is, how are they attached to each other? They're in different parts of memory. And one part of them is their data, in this case names, Sue, Joe, Phil, George. But the other part of the node is a pointer. And what this is the address of the next thing in the list, the next link in the chain. So this is going to be Sue and then 1125AF, right? And 1125AF is going to be here in memory where Joe is. And Joe's going to know where Phil is, and Phil's going to know where George is, and George is going to be the end of the list, so the pointer is going to be null. The tail is always null. And what I had done just previously to this in the video is I had dequeued. I had taken away the first. This was called the head before. It's missing now. I just erased it. but it was the head, and all we did is we changed what the head was. Head was no longer this, the head was this dot get next. And it is kind of cool, and I wish that we had time to go into a lot of details, but that gives us a good head start into it, and the video's there. So diagrammatically, here's our queue. The first node in the queue is Joe. Joe points to Bo. Bo points to G. G points to Sue. But we keep recorded a variable called head, and head is going to be the same as the beginning of the list. So as soon as we've used Joe, right, and we don't want Joe's been served, for example, right? Joe no longer needs to be at the head of the list. All we do is we say Joe's pointer, that address becomes the head. So let's say we were finished with Joe and Bo was located at 111222. Well, 111222 would become the head. So the head would then point to Bo. Well, the one thing I will point out for sure right now is the methods if you're going to implement this, which and here's the thing to reinforce one more time. To get this, you will not implement your own list, your own queue, or your own stack because of the next sentence. It says, it is characterized by the appropriate use of existing tools. You don't have to make your own linked list. You don't have to make your own stack or queue because it already exists, right? There already exists a couple of classes, and that's what we'll do. That's what we'll do right now. We'll use the couple of classes that do have these things. And you should then implement those three, use those three in your dossier if you're using a linked list as a stack. And you should use these three if you're implementing a queue in your dossier using linked list. I kind of want to show you the old-fashioned way of doing it from the old curriculum. See if I can do this really quickly. In the Java Revolution, if I look up a linked list, yeah, this is what you used to do in the old version. You used to make your node class, and it had the data and the next pointer. And then you would make your remove last in, add to the list, is empty. You do all these things yourselves, but you don't have to anymore. So let's use enqueue, dequeue, and isEmpty back in NetBeans. So we'll make a queue. And queue is the easier one to implement. So let's go back here, make a new class. We'll call it QUEUE for dossier. I'm going to call it demo. Demo queue for dossier. So this is working. I'm really happy with the way this is going in NetBeans because this is showing you the things that you can throw in to get those extra points. You can do, what did this one? A recursion. So let's change the name of CodeCamp Day 1. Refactor it, please, to be recursion example. So the four things I'm saying so far that you could throw in are a recursion example, using a 2D array, and the recursion example, now I'll have to rename that one more time, sorry. Recursion introduction. Yeah, that makes more sense. So there are actually only three things that you could do for the dossier. So demo queue for dossier, for recursion in dossier, and let's just change this then to be TWO. So anyway, demo queue for dossier. We're going to use either linked list or array list. And frankly, HL linked list is better. Either are fine, frankly, but and I'm just going to check this. Yeah, is empty. See, there's my is empty function. So let's go. Linked list. I'm not going to do LL because it doesn't look like an LL list. New linked list. We're going to import it. We have seen this before, but now we're going to see it in the context of queues and lists. So the other thing that we need to do is we need to make it a certain type potentially. And I think we better, I'm looking at the clock, this is going fairly quickly, so let's make a template class. And we'll call it Pez. How's it spelled? Z? Pez. And Pez is going to have flavor, two Canadians here, so we're going to spell with OU. Private string flavor. And one other thing about our Pez's. Character, yeah. String character. Who is this? Daffy Duck. And I can put that as a default value because if it ever comes up like Daffy Duck, I'm going to realize that was my default value. So, and we better do it a little bit more. And we probably will need a get for each of them. All right. So we're going to make a linked list behaving as a queue or a stack of these Pez's. And so we're going to go linked list like this. Pez is a new link, and this is where this is new to me, and I've done it wrong before. Is it like this? There. Is that the way you do it? I think that's the best way to do it. Linked list of type Pez called, we better call it Pez list. So Pez list is a new Pez linked list. And so what we want to do is treat, it would make sense first come first serve, right? So we're treating, and this is getting a little bit weird. I probably should pick something else, but the Pez itself works as a stack, right? first one in, last one out. But in me giving these pezzes to you, you guys are here, you get them. The others don't get them. First come, first serve. So let's just write this. Handing out Pez candy things as first come, first serve. So we're going to go Pez list dot add, but we want to do what it's in the notes, and they want NQ. So is it called NQ? Can you find an NQ? No, that's too bad. Do I want to do something really fancy here? I do. We're going to do something fancy, and I'm looking at the clock. If we can finish this by 4, we're going to take linked list, and we're going to make our own queue that's going to inherit everything from linked list and is going to reframe add as NQ, and is going to reframe, I don't even know what it is, like get's going to be called DQ, and is empty is empty. This is really, really good stuff, and I would like you to do this and understand it, and I'll probably have to do this for everybody because it's such a good idea. Go on up to your code camp, and let's go new Java class. And let's call it ISP, or custom QUEUE. And custom Q is going to extend, guess what? Begins with L. It begins with L. It's going to extend, yeah, linked list. So it'll have everything that linked list has got. And we have to import it, do we? What do we do? Yeah, import it. Yeah, cool. So our custom queue okay, so we're going to have public void NQ, NQUEUE. And it's not going to do anything, so it's going to super add. But we should take the one that's most similar to queuing, and that would be adding last. Because in a queue, when you go to the queue, you go to the end of the line, right? So we're going to add last. So our NQ will add to the last. So it's taking the way that the linked lists add last works, and it is NQing it. Now, how does NQ work? Let's go over here. Add, so add last takes in a Pez E. So we're just going to say an object. It's going to take an object O. So let's go object, whoops, up here for the thing that it takes in, object O. Why didn't I like that? Let's leave it that way for now. And then public void DQ. Oh, it's going to return. Sorry, I'm pausing a little bit here. At last. It is void of a return value, but it takes in a Pez. Anyway, let's just super. So DQ should be what? If it's a Q, what should be, when we're taking something away from it, what gets taken away? Do we get the first or the last? Correct. Get first. Yeah, this shouldn't have anything in it. That's what's in Q. Yes, it should. Oh, we just need, right. Here is what we need. Object, O, and this needs to be O. So I was hummering and hawing there for a bit, but I can explain it now. So that's it. That's it. Is empty. Oh, do we have an is empty? It's there already. So we can just use it. We don't need to rename it. We can just use it because we're extending linked lists. So we don't need it. We're done. So what that's going to do for you guys in your dossier to get you up to maximum points, if you want to use a linked list as a queue, you will be using, as they suggest, these three access methods, even though the Java linked list doesn't have NQ or DQ. We've just renamed their add last and get first to be those. Isn't that good? Does it make sense? Kind of? Okay. Yeah. Good. So now what we can do is not make a linked list, PES, but make a custom queue. Now my question is whether or not we need to put that thing there. But let's just try this and see. I've never done this before. Custom QUE is a new custom queue. And it probably doesn't want this or need this, so we'll just get rid of that. All right. So we're just going to go maybe through. We'll ask 3 people in a row, you know, if they want something. So let's go Sout. You are the first in line. What kind of PES do you want? Obviously, if I thought about this before, I could have done a bit better example. Oh, this will work. What flavor? And we're going to go string flavor. We don't have a B reader yet. And do we need to ask them? Yeah, sure, the character. So is that what we called it, character? All right. So they will have given their choices, and we'll add that to the beginning of the queue. So we're going to go PES, P assign new PES, and it's going to take in flavor character. Did I miss one line? Yeah, I missed one line. Okay, so there's a new PES, and that PES is going to get added to the queue. So PES list, I call it up here. I'm going to call it PES queue. So we're changing this. QUEUE, PES queue. So my pes queue, what are we going to do? We're not going to add. We're going to NQ. Isn't that nice? We've got all these other things that linked list had, but we're going to use our own NQ. And what's it going to take? It's going to take P, and that's fine because P is an object, and it should work. And could have had this in a loop and so on. What's the best way to leave this? Let's just put it in a regular loop. This is kind of silly in a way, but to keep this condensed, and again, people are going to look at this that didn't see this during the code camp and want to use it. And it is going to just to be clear, like there's no time for me to do this again outside of the code camp sort of thing. So if people want to get their extra points, move up to a 12 instead of a 9 or a 10, then they're going to have to watch this and figure out it's not that big of a deal. And I think it'll make more sense if we put it into a loop. So I'm going to copy all. Just going to cut it, I guess, is the easiest thing to do. And I'm going to make a loop for 5 kids, let's say. I is less, or I plus plus. And I paste all that in there, format it. And it's not going to be the first, since you are... I'm going to go, see if you can do this one with me. I think you can. You are I plus 1 in line. Right? You are 1 in line, 2 in line, 3 in line, 4 in line. You got a plus here someplace. Maybe put parentheses around that so you get what we're doing. We'll say number. You are number 1 in line. What flavor of Pez do you want? What character of Pez do you want? Okay, so after that we say, okay, we'll get orders ready. And then after the orders are ready, we're going to dequeue off the queue. And the first person's going to get the first order. So for 5 times, we're going to say, and we'll be able to end pretty quickly after this, I think, for this section. We're going to say customer number I come get your Pez of flavor PezQ dot DQ. So DQ dot, I think this is going to make sense to you, dot get flavor. Oh, DQ, sorry, okay, this is our problem over here. DQ, we're returning something. We're returning a object. So get first, return, super get first. That's better. That's why this stuff is so good. The higher level stuff is so good for understanding the basic stuff, because this is a great example of the difference between return methods and void methods. The NQ, we just stick it on in its proper place. We stick it on at the last. It doesn't return anything, we just stick it on. Whereas the DQ, we're returning something. What are we returning? We're doing this generally, so we're returning an object. And what is that object? It's the first object. So that'll work now. So that right now is dequeuing the object, but we want to use the object dot get flavor. Why didn't I like that? DQ. Okay, it's 4 o'clock now, so I'm gonna make this work, and it may not be the best way to do it. I'm going to go here and I'm going to say it takes in a pes. This no longer becomes very general. It becomes just for working with peses, but that's okay. That's probably what you're going to do anyway. And it's going to return a pes. And we're forcing it to return a pes. We're making that super get first to be a pes. And now everything's fine. And yeah, that's an okay place to leave it, because that's the way you're going to do it anyway. It's not the way you would do a general custom queue. You can only use this for peses, but you're only going to use it for peses or whatever you're doing in your dossier, so that's fine. So 1 through 5, it should tell the customer the flavor they're going to get. We do the same thing for the pes dispenser that they're going to use, but let's just make sure that it works, and then we'll take a break. And that is stacks and queues. And I do this 5 times, which is unfortunate, so I'm just going to do, I don't know what, strawberry? Daffy duck. Blah, 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 blah. And so now it should go through and give them in the correct order. So what didn't I do right? So we said that there's get first. Is there remove first? Yeah, that's what it needs to be. So get first, and I don't know what this is. Like I say, I've only used this class a couple of times, and usually the get will remove it, but in this case it doesn't. So what we want to do over here is make this remove first. I think that'll work. So I'm going to save all, and we'll try it again. So they all lined up, and they were in a queue, and they made their orders, and when it came time to get their orders, the first person there was the first person to get theirs. And it worked. So that's the end of part 2.